I'm Mazen Merkawi from the World Health Organization. We ourselves have a visualization dashboard to share the SDGs. You know, WHO is a custodian. WHO is a custodian for about 20 SDGs, and you know the SDGs are being followed by different users, including the decision makers. And decision makers usually they don't want to see the raw data. They don't want to see the information. They want to see maps, see figures, see reports. It's always good to listen to people working in supercomputers. Let me introduce Ilya Zaslavsky. I hope I pronounced it properly. He's from San Diego, California, the San Diego Computer Center, working with spatial information. Just to quote a couple of keywords from his speech, he will be talking about visualization and SDG indicators. You know, visualizing the results of surveys is something I'm sure the decision makers want to see. Floor is yours.
Thank you very much for the introduction. My name is Ilya Zaslavsky. I work at San Diego Supercomputer Center, University of California, San Diego, and I will be mostly showing demos today. I will have just a few slides to start, and then we'll dive into how the system actually works. So mostly I work with large information systems, with distributed data and data science and geoscience applications. This project started as a toy project where we looked at some biodiversity, camera trap images, and survey data, and eventually it started life on its own. This is the first session that I'm doing at this meeting. I will also have a second session tomorrow where I will talk more about what I actually do at work. But here is a system that we have actually started using quite extensively, and we see that it is being used around the world. I have about 250 users from different countries. System is called SuAVE, which stands for Survey Analysis via Visual Exploration. It was funded by National Science Foundation, and we used it, as I said, in multiple data sets. You can analyze survey data or geoscience data sets, or even try to look at pictures of Van Gogh and see when he started to paint himself on one side, or look at pictures of Picasso paintings and see and detect the blue period by yourself. But these things I'm not going to show at this presentation. I have a stand outside, and you're very much welcome to stop by, and I'll show you some fun applications of this technology. So it's been used, as I said, in lots of biodiversity studies, and there are examples from Florida Museum of Natural History, from MAGIC collections, so-called Magnetic Information Consortium, and others. Some of them I will show today. So the system is called SuAVE, and you may know that this is also a brand name for some shampoo. So just to make sure that you don't confuse these things, some people do confuse them. So I tend to get emails every couple of weeks that request me to provide some lotion. And I learned a lot about what's going on with the company over the over the last time. But that's also a sign that we are sort of becoming popular. So when people search for lotion, they find us. I don't know why. Anyway. What our system can do, and I will show you after just a few slides, is it's a very simple way to publish your own data. You can have a spreadsheet with household surveys or geospatial data, and you will all data are in the cloud, so you will connect to our system in the cloud, load the data, define how it should look like visually, and then you can analyze it with some simple statistics or more complex statistics. I'll show you. Create maps, do visualizations if you have image data to visualize. Then you can also annotate this data and share annotations with others, and in this way collaborate with your partners if you have a distributed team of people. So it's been used in all of these different applications, from public opinion surveys to political surveys to surveys in biology and ecology and in a few other areas. And most recent addition is a connection with Jupyter Notebooks. How many of you have known this word, Jupyter Notebooks or Jupyter Hubs?
I will show you how it works, because this really makes the system very powerful. It can now process data that you have in the survey by analyzing images, by doing some statistics, and return the data into the survey. So that will be the focus of the demo. Well, this slide I don't need to explain you. In fact, I'm not an SDG researcher. As I said, my research is mostly in large distributed systems and in data science, but I've been always looking for interesting data sets to load in the system, and that's a way to demonstrate the capabilities of it. So at some point I ran into SDG Index website and loaded this data, and it turned out that it provided some very interesting insights about how different indicators are related and how you can explore them. So about 2 years ago, I gave an Eye on Earth webinar that was attended by about 300. There was about 300 participants. The number of people who actually were listening was certainly smaller, from 77 countries. And after that, I saw a huge increase in the number of accounts that have been established in the system, and people started publishing their own data. I'm not going to show you that survey, because actually in the last 2 weeks, I loaded a new version of the data, and I added some additional notebooks that will that I will be showing to you. As I said, there are some very interesting issues, especially given my background in large information systems. Similar things are being faced by SDG communities. So you have to integrate data that come with different semantics collected in different by different groups with different mandates and different interests, and under different assumptions in different populations. That requires some massaging of the data and unification of definitions and conversions, which are not always transparent. And it's very important to make these conversions and the whole provenance of the data as clear as possible so that you can trust your comparisons. That's a very common problem when you deal with integration of data from multiple sources. Then you have data integrated from multiple hierarchical levels, national statistical surveys, national geospatial agencies, projects, other groups that collect data. They all provide something useful that would need to be integrated into global international comparison of SDG indicators. In the previous session, the technology that was presented was SDG hubs from Esri. That kind of does something similar. So you can have multiple sources, and I will show you in a demo how you can connect to, for example, UN statistical data and grab data from there and put it on the visualization. It's still a very complex process of how you converge on indicators, because there are some top-down ideas of how you should measure progress to sustainable development goals, and then there are real capabilities that need to be improved in terms of measuring these goals in terms of convergence. And finally, what is critically important is that everybody should be able to have very easy access and very easy way to operate this data. I think this is, all these points is something that SuAVE responds to in one possible way, and I'll show you how. All right, demo. Let me end the slideshow and get to the demo. And by the way, everything that I'm showing is available on the web. It's available for you now. You are free to get to these websites, play with the data, load your own data, explore what exists, and so on. And also, since you know how quickly things load is a bit unpredictable, feel free to interrupt me with questions as we wait for the system to respond. Okay, so these are all 194 countries, and well, not all, but 194 countries that I loaded from the most recent version of so-called SDG Index. There's a website, sdgindex.org, that you can navigate to when you click About Survey, and you can grab the data from there. So what you see here is that there are a bunch of indicators that you can look at, and that will very quickly give you distributions. You can point at any country and have information about all the values that exist for this country. You can do subsetting. So for example, you're looking at, let's say, undernourishment, and you are interested in how that distribution will depend on, let's say, and here you can help me because you are professionals in SDGs. Suggest what indicators I should throw in, because that's all totally possible. So let's say we look at a subset of the data, right? And we can see that if you're looking at, is it? Oh, yeah. If we're looking at subset of undernourishment data, that the distribution will be slightly different than before. So it's very easy to compare with the original one. You can also see how it looks. Yeah. It's GDP per this one?
No, the main one, when you show all the facts on the
That was undernourishment. So you can percentages from 10 to 0 to 10, 10 to 20, 20. So percentage of undernourishment, yeah. Yeah, right. Yeah, so in the same fashion, I do not redefine the variables here, but I can show you how you can do that with Jupyter Hubs. So, so as I said, you can look at subsets, and you can, look at the maps of those countries that you subset. You can, that's healthy life expectancy, so you have certain, other countries than before. If you find something interesting, either on any of the views that we present, you can comment on this, and then this comment will be saved by the system. You can also share this with others. So if you are interested in sharing this within your international peer group or international group of researchers, you just copy this data, this link to your Facebook account, whatever, Control V, right? And then your partners will be able to jump into this specific saved point in the application and start their exploration from there. So essentially what you can do when you write a story about what you find with the data, you can illustrate this story by links to such saved views, so that you can kind of prove to the reader that this is real. You can jump and try to play to understand the data on your own. That's what I just did. So something that is probably most interesting here is that you can now start Jupyter Notebooks. We had before, and we still have integration with R statistical package, so you can run models from this system. But connecting with Jupyter makes it really boundless in terms of what you can do with the system. What is interesting here, I can connect to any number of Jupyter hubs. Again, I guess I need to say a few words about what a Jupyter hub and Jupyter technology is. Imagine that you have a framework where you can write some executable code on the web and execute it like cell by cell, and also document it, so that when anybody runs this code again, that person will see what you have done step by step, and will see your notes. So that's essentially you sharing your notebook about what you've done with the code. That really helps when you are trying to understand what went into the results, and when you're trying to reproduce these results. So that's a way to do reproducible science these days, to share notebooks. Why I'm trying to do it on multiple hubs is because they all have different capabilities. So for example, this second one allows me to provision fairly serious resources. I can, such as graphic processing units to run machine learning tools, and some additional storage. The third one is a free one, so something that you will be able to run without authentication. The first one is what we use on our small development server. So I clicked on it, and you see what happens. I'm passing parameters about this data set to the Jupyter Notebook. These parameters get converted to Python variables. So now the demo is kind of running, right? It's everything that you can do by yourself eventually, and then it offers me a bunch of options of what I can do. I can, if I have a collection of images, and this is what we have when we work with biological surveys, where you need to do taxonomic assignment based on models, and here you can actually develop models. You can do support vector machines, you can do color extraction and image processing, and also you can generate SDG datasets by going to UN statistical, SDG time series database, or in the same fashion, you can go to any resource that provides some API or provides some data that you can grab and construct your indicators from. So just to give you a very simple illustration, I'll do arithmetic operations. I'll start another notebook, and one thing that we have done differently compared to what other people have done with Jupyter Notebooks, we opened them up so that you can call them with parameters. So imagine that any notebook can call any other notebook with parameters. They can call HTML, applications, or any HTML application can call these notebooks. So your internet becomes sort of a collection of executable code and interfaces, and that is a fairly powerful new concept. So, but for simple variable calculation, let's say that we are looking at, again, I'm running this very quickly. Let's see if these are all the variables that I have. Okay, so I'll divide goal 2 score by goal 4 score, whatever that means. Oh, goal 2 is eliminate hunger, right? Goal 4 is improve education, right? Where countries are with respect to these goals, you can compute the ratio and look at it on the chart. So next step is I just compute the variable. I will give it some name. Let's say SDG 55, whatever. You can see that there is a lot of code there, but I'm not actually doing any coding, right? If you are interested in coding, you are, of course, very welcome to look at all of the things and change it. But in reality, you don't have to. You can just click through these cells, which are pieces of, fragments of executable code, and eventually end up with a new survey data set that will be opened in the system that will include these additional variables that you compute. Right, so in this same fashion, you can compute any types of variables collected from any sources and add them to your visualization. So here I have a new variable that I just added as goal 2 divided by goal 4 score, and it may be interesting to look at distribution by countries. So there are some countries that value goal 2 much or much further away in terms of goal 2 than goal 4, and you can look at other countries as well. Questions so far? Okay. All right. Now, another example of how we would grab data from United Nations system. So I'm going back and starting another notebook, which will show me, which will give me this interface where I can again just run it through cell by cell. And it's taken some time to realize where it is. Then eventually it will load that big collection of data, allow me to subset it by year and by indicators. So let's see, I'm loading SDG all. And then I can select So yeah, so now it's a fairly large data set, so it may take a few seconds to, well, maybe a little bit longer to load. And then I can select any variables that have been collected by UN statistical agency, statistical division, and add them to our visualization. I guess it's taking a little bit longer. So I will just jump. Okay, now we're there. 273. And that. Selecting some years. All right. Besides SDG, the system has been used in multiple other comparisons. So this is something that I'm working on with National Science Foundation, where you can look at comparison of science and engineering indicators by countries. And again, that's an example of a saved view where I can show China versus US in terms of number of articles in science and engineering public journals that have been produced. So it's interesting to see how in different fields the relative volume of publication changed over years. So just one more example of what you can do with the system. As additional example, it's been used by actually in quite a few other international projects. One of them is what was presented yesterday as so-called Global Forest Link. That's a project that brings together school kids from about 8 countries in the world that exchange information about forests. And part of the work that they do is go to forests, take pictures of forests, and then relate them to satellite imagery, and also collect some data about those photographs. Then they can they can compare those photographs and analyze trends in forests across these different countries and write stories. So that's a fairly popular project these days. So types of applications. Since we are in Earth observations group now, we still have a few minutes, right? Yeah. I will show you just one additional application here that deals with Earth observations. And that's something we've done together with NOAA, where you can look at all observation systems operated in the US and see which of them measure which variables. So these are the different systems. For each of them, there is information about what the system covers. And if you're interested in those that, let's say, measure temperature, let's say sea surface temperature and ocean temperature, that will show you those systems that contain, have this data. So it's kind of a very easy way to have a catalog of a large collection of resources, and then this catalog can be updated in real time by grabbing data that exists elsewhere. Okay. Since we don't have too much time, I will skip the next short slide because what we actually are using this system now for is machine learning over collections of images. So this is, for example, biological collections, some butterflies, where we want to do fairly precise taxonomic identification by doing machine learning. These machine learning models can be built all within the system that I have shown you. Since I have about 30 seconds left, that will be just enough to show you how you can publish the data. Okay, so I'm not going to show you how to publish the data. I will do it at the stand. But once you have a CSV file, it takes virtually like 30 seconds to point to that file, give it a name, and it will be online. And just a take-home message is we have a fairly user-friendly platform that can display SDG data or any other type of data that you have. It could be household surveys, could be environmental data collections, could be biological collections. And it doesn't, a powerful system doesn't have to be difficult to use. It's actually very easy to use, and you're welcome to use it now. Also, if you want to make it really powerful in terms of connecting to other sources, such as Jupyter, connecting with databases and services via Jupyter Notebooks, that's also is available. And using the same mechanism, you can build indexes that would support directly policy-making decisions, something that would sit on top of SDG indicators and provide some additional information for decision makers. In a sense, it's a gateway to advanced data science tools that you can use in education and in research. And finally, I want to invite you all to explore that. Suggest data sets to publish, suggest notebooks that you would want to use to connect to other resources, and thank you. I'll take a few questions.
Thank you, Dr. Ilya. I think there's quite an interesting system here, but I just wanted to know how the data is being populated. It's mostly, by the user. So it's really up to the user what kind of data he wants to populate and how to use this data. So it's not like, it is the system that you develop for the user to make use of it. But it's not like a portal that trying to collect data, volunteer from different sources and publish it. Is it?
I think these are not totally opposite ideas. You may, users are of course welcome to publish their own data, but they also, once you create an account, you have your personal gallery. And you can populate, you can make surveys in this gallery public, or you can keep them private. So anybody would be able to access your survey gallery and search for what surveys you have published, and then if they want to work over your surveys, they will have to clone this survey in their own gallery. So it's a fairly large system where people can exchange survey and publish survey data. As to how you find the right surveys, and let's say there are thousands and thousands of surveys. I don't yet have thousands, I have hundreds. So how you find them, that will be my talk tomorrow. Not related to the system, but it will be a large geoscience data discovery system.
Just a single question about ML, machine learning. If I, for example, buy a high resolution image or a drone image, which is a mosaic, I can reload and search for something. For example, we are conservation guys, we help the community conservants mostly to search, for example, for human footprints, which are poachers. So is that possible? Just load my data and try to search using ML?
It's possible.
It's possible. Yeah. Thank you.
Ideally, we would need to talk with each other because we, since we don't have unlimited space on our servers, we don't allow anybody in the world to publish their images. But it's just a matter of knowing who is doing that. Technically, it's all possible. We opened it up for a little bit sometime in spring, and we get the survey filled up in about a week. So